I'm going to talk to you today about how to port these engines, these 63cc engines. I wanted to do a how-to video, but the problem is these engines all vary slightly, so the port work that I'm doing here is probably going to vary compared to your 63cc engine. What you really have to do is measure up your port timings and then refer to the table and make the adjustments yourself. I've already measured up the port timings, the transfers, the exhaust, the intake timing, and when the exhaust opens after top dead center. I'm not going to tell you how to do this. There's loads of videos, and I'll post a link from some Australian guy actually on YouTube. He does a really good job of explaining how to measure those stuff. But I've already measured up, and I'm making a note, and I'm going to tell you what adjustments need to be made. So there's three different ways of approaching porting. There's what people consider mild porting, which is, if you ask me, quite pointless. It's when they're well, they call it port matching, where say your manifold might have a bit of a lip, or there's some casting imperfections in there, so you want to smooth it out to aid the flow. I think in reality, that doesn't really make much difference to performance. And then there's adjusting the actual area. So obviously, if you increase the port's width, you're increasing its area. If you're increasing the port's height on the exhaust port, for instance, you're actually, as the piston's descending, you're adjusting the point, the angle in which the port is open, which will be called port time area. So obviously, if you increase the roof, raise the top of the port up, you're going to increase the area, but at the same time, you're increasing the amount of time that it's open for within that cycle. So adjusting port time area is more effective, or the most effective way of doing porting. You can then move on to increasing area on its own without adjusting timing. If you need to, if you want to tune your cylinder to a specific exhaust pipe. And here's the port durations, which I've already measured. Here's the transfer port duration in degrees, so it's open for 120 degrees of the rotation, and the exhaust port is open for 155 degrees of a rotation. So this table I've taken from the internet, Marty's Garage, and it gives us an estimate of what the timing should be for the transfer and the exhaust at specific RPMs. So you can get maximum power at 6,000 RPM with 120 degrees of transfer and 158 degrees of exhaust duration. And you can see, especially the transfers are massively low, and the exhaust is as well. So we're probably looking at about maximum power at about 4.5k, 5k. And these engines are really torquey, so they do have low end, so that corresponds with the port timing. But what we want to do is pinch a bit of that low end power and put it in the high RPM range, because that's where two strokes perform at their best. So basically what we've got to do is increase, another cylinder, is increase the transfer timing by raising the roofs of the transfers. Now, as you can probably appreciate, getting a Dremel in there is risky business, because it's going to snatch, you risk scoring your bore, and it's really difficult to take. We need to probably take about 3mm off the top of those transfer ports. So there's a cheating way of doing that. So here's the piston, and it's called ramping or notching the piston, where literally, so the piston sits in the engine, and we can see the transfer ports are either side. We grind or port a little notch out the side of each side of the piston to make a slope, so on its way down it actually opens sooner. So basically, rather than porting the actual ports, we're porting the piston instead. It doesn't do very much for your squish band, but the gains you get from doing that far outweigh the losses you get from ruining your squish band. So that saves you destroying your cylinder. And you can do something similar with the exhaust port as well. You can cut a notch out of here so it opens sooner in the cycle. But what we do with the exhaust port, so I've got it around the wrong way, is we raise the exhaust port, and that increases the duration. So basically, by notching the sides of the pistons, we probably gain about 10 degrees. You want to leave, if you're looking at, you want to leave about half as much material on there, so you only want to go down about halfway, because if it's too thin, it'll melt, it'll burn off, so there needs to be enough meat left on there. You get about 10 degrees extra, so we're going to be looking at about 122 degrees, so we're moving up. It's probably a bit less than 10 degrees really, but we're moving up into the 6,000, 7,000 range, RPM range. And then we just raise the exhaust port to correspond with that. So we're going to aim for about 160, 165 degrees, I think. So we're going to have maximum power around 7,000 RPM, which is much more sensible. A lot of GoPed clutches engage around that area. Also, the intake duration is quite low as well. Ideally, you want about 140 degrees of intake time. So if you're looking at the intake side of things, as the piston goes up, we can actually increase the intake duration by just shaving a bit off the bottom of the piston. So we'll do that as well. We'll shave it off so we got 140 degrees of open duration for the intake timing. You want to be careful how much you raise the exhaust, because as the exhaust opens, well, basically as the gases burn, the the piston goes down. The exhaust port should open around 90 degrees after top dead center, so it does a quarter of a rotation before the actual port opens. Any sooner than 90, some go to 80, any sooner than 90, then there's not enough time for the gases to expand and to force the piston down. It loses power. But fortunately, we've got quite a high degree measurement from top dead center, so we can easily lose 10 degrees just by taking the top of the piston, sorry, not the piston, the top of the exhaust port, and still not be detrimental to the power of the engine. Another problem I see quite a lot with people porting engines is they just focus on the exhaust port. They just raise the exhaust port and hope that you get the power. And then you can imagine if you raise the exhaust port up but don't adjust the transfers, and let's do an extreme example. You go right up to 190 degrees, but it stayed down here at 120 degrees of transfer duration, then you get what's called a high blowdown, and that's the difference between the transfers and the exhaust, and that is very detrimental to the performance of an engine. There's a balance between how much exhaust duration you have and how much transfer duration you have. You can't really increase one without the other. They need to go up together. So if you make any adjustments to the exhaust port, then you need to do it to transfers as well. Right, porting complete. I'm pretty pleased with how it went. As you can see, I'll start with the piston. I've ramped the piston, and you can see that slope, and that's either side where the transfers are. And after I'd done that, I got a result of a duration of 122, which was 10 degrees higher than what the original 112 was. So I'm up into the 7,000 RPM range for my power. What I did was create this little stencil and mapped out where the transfer ports were, and then marked up the piston which corresponded with the stencil, and then that gave me an idea where I needed to make the ramps. I'm going to replace the old gasket, which is quite thick, with a thinner gasket which I just made myself, which essentially lowers this, makes the squish band smaller. And I raised the exhaust port. And once I raised the exhaust port, I got another 10 degrees. So I've got 165 degrees duration on the exhaust. And I increased the intake, like I said I was going to, by machining a little notch out the bottom here. See that? And I've got that to 140. So I'm looking at now, I'm just 2 degrees short, but that's fine, of maximum power at 7,000 RPM. So it was right down here before. The next videos I'm going to do will be of me testing it out.